Good morning. Thank you for all being here. We're going to give everyone a minute to settle in. All right. Okay, welcome to the 34th installation of the Panitch Training Academy. Today we'll be discussing the patenting of AI-based inventions. And hopefully we will go into some details that will be helpful to you. There are some important Zoom tips, and they are, as just a reminder, that this session is being recorded and it will be available on our website by the end of tomorrow. We will also send it out to you if you like, and we will follow up with any questions you might have over time. Please feel free to ask questions during the chat. That's actually encouraged, or Q&A, and we will be keeping an eye on those. For those seeking CLE in Delaware, Georgia, Pennsylvania, or Virginia, make sure that you stay for a while for the entire session and respond to the two pop-up polls and fill out the feedback survey at the end in order for you to receive that credit. I am very pleased to introduce my very esteemed colleague, Sean Douglas. We've been working together for
almost 6 years, I think, now.
6 years. But Sean has a great background. One of the reasons I was so excited when he joined us was that he started at IBM, and he started at IBM on blockchain and AI, two of the hot topics. That experience with blockchain, for a period of time, we were the #1 filer of blockchain applications in the United States for about 2 years, and Sean was part of that. And now AI is the next huge thing, of course. It has been for some time, actually, and Sean has more experience in this than most patent attorneys. I think many of us learned to spell AI about 3 or 4 years ago, and so we're just getting caught up now. With that, Sean, I turn it over to you.
All right, thank you, Chad. Yeah, I just feel like I should have had the Simba's dad holding him out over Pride Rock during the in the background during that introduction. But thank you. So this session is going to cover kind of a slew of topics about AI and patenting and how and patent practitioners can utilize AI in their practice. So this is a quick session overview slide, but I won't spend too much time onto it. I'm just going to jump right into it. The first section here is kind of basically a short history of AI, because I like to make the point that this really isn't a new thing in our lives. Pretty much everyone in this webinar right now, AI has been around since before you were born. This is a kind of an older definition that started in 1950s when the term AI was first coined by John McCarthy. And it's just the science and engineering of making intelligent machines and intelligent computer programs. Obviously, today it's evolved a little bit more and going to become a little bit more specific about machine learning and deep learning and problem solving. But again, it comes down to the basics thing. It's computers increasingly doing more and more what humans used to be able to do, or still do, hopefully for a little bit while longer. But so this is a kind of a next two slides just show kind of a timeline of the history of AI that I think is a nice illustration for people to see. All the way back to 1651, Thomas Hobbes was the first one to kind of link reasoning and mathematics together. And that was kind of the genesis, we can say, of AI. And then you can kind of follow along here, and you had Ada Lovelace writing the first computer program in 1843, down to the 40s and 50s, where we get into Alan Turing, the Turing test, asking whether or not computers could understand or could act like humans to begin with. All the way through kind of the 80s is where you start getting into backprop, kind of more things that we think of as today, more current AI type algorithms of backpropagation and neural networks start to become a thing. And then kind of more into our more recent past in the 2000s is kind of when we start getting, the bots that we are familiar with and are utilizing probably every day. We have IBM in 2012 or 1997 rather, we have IBM's Watson beating Garry Kasparov in chess. And then in the 2012, I believe, is when Watson won Jeopardy, all the way through to today, where we kind of, I think ChatGPT has probably become a regular part of our lives. So again, this was all just to kind of show AI is not new. It's been around in our lives. Whether or not you've realized you're utilizing AI or interacting with AI, it has been a part of your life pretty much since you can probably be using a computer. Um, with that said, I like to kind of then break down that history into kind of these overlapping Venn diagram bubbles to show you kind of like how AI has evolved and kind of what we mean when we actually say AI nowadays. So AI is obviously within the whole realm of data science, and then it's a particular type of algorithm essentially, and then with the kind of basic version of intelligence is what we call reactive artificial intelligence, which is basically it's programmed to give you a predictable result. So no matter when you put in one thing, it will always give you the same thing. It's pre-programmed that way. The best kind of example of that is kind of when you call like your bank and it says press 1 for English, press 2 for Spanish. You press 1, it goes into the next sub menu and it says, do you want to check a balance? Do you want to make a transfer, et cetera, and press a number. So they're pre-programmed numbers that walk you through kind of a decision tree. And that at its core is the most basic type of machine learning, of artificial intelligence. And then kind of more beyond that is the actual machine learning algorithms that we kind of utilize more and more today. And those are more, it allows for optimization. So it kind of helps you make predictions that minimize errors. You can kind of think of these ones as more analyzing data and then making recommendations based on that data. Kind of like Amazon, like when you log into Netflix and it says you may like X. It's based on kind of analyzing your history of data and then saying you might like this program because it's in a similar subcategory. So again, it's not that advanced, but it's kind of starting to get into the area of that we're more familiar with today. And then you kind of get into the more deep learning features of your artificial neural networks, your concurrent and recurrent neural networks. And we're going to get into a little bit more detail about what that all actually means in the next couple of slides. So I won't go into it now, but that kind of gives you a breakdown layer by layer of what artificial intelligence actually involves and what we refer to it when we say it. So the kind of at the basic beginning of we need to kind of understand how AI works as patent practitioners and to inform how we draft patent applications. You need to know all of this kind of information to be able to successfully enable the inventions you're disclosing in a patent application. So we're going to go walk through a little bit of that as well. And you also need to know this because it will inform how you interact with AI in kind of applications in your practice as well. If you're using AI to draft, AI to answer, help you with office actions, et cetera. It helps know how these models are actually using what you're interacting with them to do, and how that data is going to be used. So this is kind of a general flow, and we'll go into these steps a little bit more. But the first step is obviously to get data. All these machine learning algorithms, all AI algorithms at their core are based on data sets. Your ChatGPT literally crawls through the internet and scrapes anything that it can find and ingests it as data. But the data can be anything to an enterprise level to a global level like ChatGPT. So enterprise level, think your corporation, all the data on your servers can be the data set that trains an algorithm to do something that your enterprise in specific needs. The next step after you get the data is to clean and prepare the data. These are just basic pre-processing steps, nothing really new there. It's kind of cleaning up, corrupted data, finding duplicate data that might be in there and removing duplicate data, just kind of cleaning up and preparing the data as needed. And then depending on the type of model that you're going to be using, you can also then pre-categorize data or sort data a little bit where you kind of put it into the right subcategories that you might want it to be in. That kind of training in this sense is called supervised learning because you as a human are you're initially manipulating the data into more defined ways that the machine algorithm can ingest in a way. But there's also unsupervised learning where you can just upload an entire unstructured data set into a machine learning model. The next step is training the model. Again, we'll get a little bit more detail on that in the next couple of slides. Then you test the model to see if it's going to give you accurate results. If it's a classification model, an image classification model, you can ask the model, upload a picture of a cat, ask it if it's a cat, get a result. If it doesn't say it's a cat, then you feed back into that data saying, no, you got it wrong, and you retrain it, and the model retrains again and again until you get a level of accuracy that you're happy with. And then you have a trained model. And again, the improving step at the end. So I think Chad's going to talk to you a little bit more about kind of more granularly how these AI models work.
And they're really fascinating, but to reemphasize, the reason we're telling you about this is when you're describing an AI-based invention, whether it is an invention about improving AI or using AI to improve something else, it really has a great deal of value when you're drafting an application to explain the technology. One of the lessons that we learned in blockchain is a lot of the inventions could have just ended, with and stored in a blockchain, and you would have crossed the threshold for enablement. But that's a black box, and examiners don't like it, and anyone could say that. It doesn't give you the sense that you have possession of the invention or anything like that. So what we learned, or actually what we started doing right away, was we would actually explain what blockchains were, and then integrate the disclosure, even if it wasn't so much on the blockchain technology itself. We would integrate the invention into the next layer of depth into the blockchain. And so with that explanation, it's important to know how it works. And there's lots of YouTubes on this, but the problem with YouTube is 90% of them are either wrong or just junk. I go to IPM's, your alma mater, Sean, because
I
they
rely
are
on it
just,
a lot too. So
yeah,
put that out there.
they are factually based, and you have people who are speaking with great authority. So when you input an image or something like that, what you have to understand is what AI does is it'll take an image of a cat and it'll degrade it. It'll literally take a sharp focus, and then it'll go to the next level of phase, fuzzier and fuzzier and fuzzier until it's down to a pixelation. And that is how you get to the truth of what a cat is. It's the catness of the cat. And then you have an army of people labeling millions and millions of cat pictures, and all of them, being compared until you get to the degree of cat. And those things are turned, and the words are turned into vectors, which are really converting a word into a concept. And we're going to, I think it's a slide or two beyond this, but you'll see that what the vectors look like a little bit. And so then it does, actually, can we change the slide? Sean, I'll just say, move the slide. Oh, so what it does, I wasn't quite done with that last slide. What it does is basically then looks for adjacent vectors. Oh, here it is. The example vector is right there. You can see that it's just a long string of numbers. And what it does is it'll look for adjacent vectors that look just like that or close to it. So that's how you realize that when you type in cat, it's also looking for kitten. But more importantly, when you put those strings together in an inquiry, a prompt, what it's doing is it's going out and finding similar vectors for each part of the prompt. And we'll explain a little bit how it parses that out. But by looking and comparing the vectors, it's pulling in different concepts. And we're going to go through the different modules about how that's done. It's important to conceptualize this because when you're describing the technology, I at least, decades of being a patent attorney, I have to understand the concepts behind it before I could really explain it.
Yeah, and I was going to say for kind of an example of vectorization, like you're saying, where you're basically turning words into numbers, because at its core, a computer only understands ones and zeros at this point. You need it to convert text and images and stuff into numbers in order for the computer to understand what is happening. And I think kind of the most basic version of vectorization that people probably heard of is called bag of words. And it's the simplest vectorization technique. It literally just creates the vocabulary of every word in the text that you've given it, and it represents that each word as that vector. It's some series of numerals to represent each word itself. And then there's kind of a step beyond bag of words where it's called term frequency inverse document frequency. It's TF-IDF. And that's essentially a kind of a smarter version of bag of words, because it not only counts the frequency of each word and assigns each word a definition, it also penalizes common words. So it'll recognize the words the, and, etc. And it'll take those kind of common words out or assign them a lesser value in the weighting. And it will highlight unique and important words as well. And so I know we skipped a slide over just to show you the kind of the vectorization aspect of it, but also I think this slide shows you again kind of how the neural networks process through vectors, kind of just like what we described to get to their output. And then I included this slide because I think a lot of people here, ChatGPT is kind of, in number one in the zeitgeist when you think of artificial intelligence. So I wanted to kind of include a little deeper explanation of how ChatGPT itself actually works. So ChatGPT, believe it or not, actually stands for something. It's Chat Generative Pre-trained Transformer. So chat meaning that it is designed to interact with you in a conversational level. That's why you're writing in prompts and it's responding to you, clarifying, et cetera, back and forth with it. Generative just simply means it's designed to generate new text, new images, new whatever kind of data you're looking for. Pre-trained, kind of like we already went through, it's pre-trained on a large data set. ChatGPT is trained on the internet and on the data that you're putting into the model. That's an important point for later. It is ingesting what you put into it, at least the public free versions are. And then transformer is the specific type of architecture that ChatGPT runs on. Transformer models are a type of recurrent neural network. So kind of essentially 4 basic steps in transformers. Tokenizer, it converts text into tokens. Embedding layer, it transforms tokens into their positions, into the vectors. So kind of that's a more advanced level of the vectorization, is kind of where on the vector and the XY axis in a 3D kind of dimensional space the vector is going to be assigned. Transform layers consist of alternating self-attention and feed-forward layers. What self-attention means is they're essentially algorithms that are designed to determine which parts of a data sequence an AI model should pay attention to. And a good example of that is illustrated below, where if you have the sentence, on Friday, the judge issued a sentence. In terms of a machine learning model, if it just looked at that sentence on its own, it could determine that judge is a verb, judge is a noun. It could determine sentence is a grammatical entity, an actual physical sentence in a document, or in this case, legal capacity. So the way the self-attention mechanisms work is it runs through the vectorization of these things, and it looks at, the word the before the word judge. It kind of implicates that the judge is being a noun. It's not being used as a verb, so they'll infer that. And then the next step is, okay, the word judge then suggests that the term sentence is a legal penalty, not the grammatical term sentence. And then the term issued also suggests that the term sentence is the legal concept and not the grammatical concept. And so in the end, kind of what that all helps this model do is that it learns, okay, when it's interpreting the word sentence here, the model should pay attention to, so rank higher the words judge and issued over the other words in the sentence. That kind of helps it learn. And it's the same, it'll process that through the entire document or text input that you put it through. So that's kind of on a more deeper level, what ChatGPT is doing when you put in your prompt and your documents that you're asking it to look at. That is kind of how it is breaking everything down and looking at it. And so the next slide, we kind of went into vector database. So sorry, Chad.
Can we go back to 10?
Oh, yeah.
I'm just going to point this out. 10 would be one before.
Mm-hmm.
The reason that it's relevant is what I was suggesting is that you have training architecture and the inference pipeline somehow built into your disclosure. That's the level of detail I would suggest. Let's go to the next slide. And for ChatGPT, one of the emphasis on it is the chat part is designating the model. And just to explain what chat means, is one of the things that we're just seeing in the news is all these things that have gone terribly wrong. What ChatGPT is modeled on is basically improv. And if you've been to a dinner party and you play a game where someone says something and then you have to reply yes, and that's improv, and your other player is a sycophant. So whatever you say, you're brilliant, and it'll continue to encourage that. It's a real limitation because it's not telling you the truth. It's just sucking up. And that has led people to commit suicide. One guy ended up killing his mother, thinking that she was after him because he was paranoid schizophrenic. It's really something that, as a patent attorney, you need to understand the tools that you're using and its limitations. So ChatGPT
Context
could
is
answer.
important.
Yeah. ChatGPT is fun. It's a lot of fun, but you just have to understand you're playing improv with a sycophant. Let's go to the next one. And we actually dealt with this vector databases again. That's something that you might want to mention in your applications. RAG. That's the other. The explanations of what these things do is on this thing. The vector database is just what it sounds like, but it enables semantic retrieval across text, images, audio, and any other modality you can think of. The augmented retrieval generation, I think, is pretty cool because it really does explain what's going on to a degree, because what it's doing is it's reaching out beyond your inquiry, the documents you upload. And that thing is the reason why it's so ubiquitous, is because it has adopted a protocol where it doesn't have to go into the protocol of whatever access it's accessing. Because of the way the vectors are stored, it doesn't have to have an Adobe reader. It doesn't have to have a website reader. It actually has a very cool way of accessing the information. Let's go to the next one. Mixture of experts. That's DeepSeek. That's probably where we want to be when we're dealing with some of this stuff, and where the patentability will be is the two concepts, the MCP and the mixture of experts. What these things do is they take it from the large language model based on the entirety of the internet and boil it down to the data set that it's working in is more specific to what you want. So if you want all the chatter on the internet, you go to ChatGPT. If you want something that's more based on scientific models, the mixture of experts is something that you probably want to identify in applications where appropriate.
Yeah, and I was gonna just wanted to jump in and say, like, if you're using ChatGPT for these specific types of models, ChatGPT has, if you have a paid version, you'll notice that the drop-down menu, they have like now probably 6 or so models that you can choose to run your prompts through. And in those versions, all the models that start with O, a little O, those are the more specialized versions of the ChatGPT model. I think as of this point, the major ones that they deployed, all the O1s, are geared for STEM in particular. So that's just kind of a version of what Chad is talking about there in the ChatGPT world.
And great point to raise. And we'll talk a little bit later about why it's important to pay for some of this. Let's go to the next one. These are the things that are coming out, and you can see we repeated mixture of experts, but this artificial superintelligence is interesting because if you believe in what AI is doing right now, it is predicting the next word, as so many people say, is predicting from the concepts you introduce what it is you want to hear from a known knowledge base. That is, it is working on maybe the totality of human knowledge as it exists at the time of the inquiry. And you could make an reasonable argument, therefore it can invent, because it's really just helping you digest information and expanding your knowledge about what the current state of the art is. When you get to super artificial intelligence, or artificial superintelligence, I should say, that when it comes online, which is predicted to be soon, 3 to 5 years, blink of the eye, that's where it's actually thinking faster than a human. It will be creating, if you believe the hype. And maybe it's not hype. Let's go on. Oh, and I do want to mention You do see a poll popping up. Please respond to that. The agentic AI is the thing that all these vendors are contacting you about, to write your patent applications. That is just a much more specific use of AI. So it's agentic.
Yeah.
Okay.
And just to reiterate, artificial superintelligence does not exist yet, so don't get worried. That's kind of like when you get into the Skynet of it all. As of right now, everything that we have is referred to as artificial general intelligence. So we're not quite at the superintelligence stage yet, and when we get there, I don't know what's going to happen, but that's when we should maybe start getting worried. These next couple of slides, I'm not going to walk through them in any more detail. They're just kind of here to illustrate to everybody kind of, how popular and AI applications have been getting, and kind of the explosion that has happened kind of in the early 2000s up through to 2017 when it really exploded. So here you can just kind of see that as of 2023, there were 80,000 utility applications at the USPTO that involved artificial intelligence. And in 2023, that is 150% higher than there were in 2002. And then the next slide just shows, this is kind of on the worldwide level, that overall number of patent applications filed by patent office in the world, the US had the most artificial intelligence applications as of 2019. I don't know how that has changed over the last 5 or 6 years, but as of then, US was still dominating in filings of artificial intelligence applications. Then also in 2009, IBM seems to be a through line for me in all of these and for everything, but still, IBM at the time in 2019 was the #1 filer in the world of AI patent applications. However, in the next slide, you can kind of see in the interim into 2021, Tencent, Baidu, all these Chinese corporations jumped ahead of them. So as of right now, to our knowledge, the Chinese companies are the #1 filers of artificial applications worldwide as of right now.
Particularly if you include the Chinese filings themselves, if
Yeah.
filings in China themselves.
Mm-hmm.
Okay,
Yep.
go on.
And then the next section here is AI and inventorship. We're not going to spend too much time on AI and inventorship. Chad and I actually gave an hour CLE on just this topic alone, I believe earlier in the year. So if you go to the Panitch website to where we have all the Panitch Training Academy sessions, you can scroll down and find the more detailed version of these next two slides. But just quickly, this is just outlining all the US code sections, the patent code that defines that an inventor basically has to be a human. Everything refers to in the patent code, declaration has to be signed. And when you're signing a declaration, you're saying that you had conception of this invention, you know what's happened, you know what's in these documents, et cetera. Only a human can do that. And the Dictionary Act and a couple of court cases also all define an inventor as being a human being. So an artificial intelligence model itself cannot be an inventor. We learned that there's, again, in the previous session, we talked about the whole case of Thaler. He went through probably every patent court and patent system and patent court in the world trying to argue that his artificial intelligence model should be able to be named as an inventor on all the applications. And every single one of them rejected him, except for South Africa, which doesn't examine applications. So that's the one outlier there. But so AI cannot be named as an inventor, but that does not mean that AI inventions are not patentable. So when you get to that next step, you then have to kind of gauge and analyze how involved was the artificial intelligence models in the conception of the invention itself. You have to determine whether or not there was a significant human contribution or not, or did someone just literally write into the chat GPT, make me a blank, and it came up with its own thing, and then they tried to patent that. That would not be a significant human contribution.
A much more realist or real life example is a group of German engineers put in various material calculations for strength of materials, and AI designed a strut for a car. And no one would claim ownership of it. None of the humans would say that they invented it. All they did was give it the math, and it came up with a design. So you can see that in whether that was an invention or not, you could debate, but there was no prompting. It was just like, here's all the math, build me a strut. And that's what it did.
Yeah.
All right.
Yep, and in analyzing kind of what is a significant contribution, the courts to date have used the PANU factors. And quickly, the PANU factors: one, did it contribute in some significant manner to the conception or reduction of the invention? Did make contributions to claimed invention that is not insignificant in quality? And did they do more than merely explain the real inventor's well-known concepts at the time? So that is kind of just the brief factors. Again, more detailed explanation in previous sessions. And then kind of taking that to the next step, these are kind of our practical tips at the invention disclosure stage of the application writing. So these next couple of sections here will be kind of interplaying each section that we go through in drafting and kind of our practical tips for each kind of stage at the drafting procedure. So here at the invention disclosure stage, when you're first meeting the inventor and talking to him and learning about the invention itself, you need to ask now about AI involvement. It needs to be a question that you ask, no matter how much you think that the AI is not involved in what you're hearing. You need to ask if AI was involved at some point, because you just can't really tell, and you need to be able to, as a patent practitioner, to satisfy the responsibilities of the patent office, which we'll get into a little bit later. You need to know that. You have a duty of reasonable inquiry, like it says. And also, you kind of have to use your own kind of common sense in this. For those of us who have used AI, ChatGPT, all these other AI models themselves, you can kind of become familiar with the syntax and the format and how they kind of output their, their findings and stuff. If it looks suspicious to you, you need to ask the inventor and push him back on it. You need to essentially, you just need to find out whether or not AI was used. And then the next step to that, if AI was used, it's not a problem necessarily. You just need to find out more information for the enablement stuff that we were kind of talking about, and we'll get into. Was it an off-the-shelf AI model? Was it an AI model they themselves generated? What prompts would they use if it was a off-the-shelf model, a ChatGPT? What prompts were they used? Do they have the history of the chat with the AI model that they can provide you with, just so you yourself can kind of determine what was going on at the time? And you want to clearly record all of this if you can. So sorry, Chad, it looks like you're jumping.
Oh, I was, but so there's a couple things there. One is the PANU criteria, for just a refresher, is you have to be an inventor, you have to contribute to the conception, contribute to the reduction to practice, or both, and it can't just be filling someone in on the state of the art. And so when you talk about generative AI, the question is, by definition, is that filling in, just informing people of the state of the art, which is expressly excluded from PANU. And I could see that you would have fact pattern to go either way. But if you notice, the IPO put out a news bulletin yesterday where that very thing about treating AI inventions differently has been questioned, and questioned hard. Now, right now, it's part of a budget process, but there is a pushback on the PTO's requirement that you reveal AI's role with material to the patentability. And the key phrase there is material to patentability. Yeah, so you do have to make an informed judgment. And the last thing I'm going to say about this slide, just generally, is if someone comes to you and says, I watched all the original Star Trek series and I want to get a patent on a tricorder, and you find out that he used AI, scoured all the episodes, figured out all the 47 different things that Dr. Spock used it for, and then say, build me this. That is not a human inventor. That's a concept, not a conception. And there's no reduction to practice. And when you talk about ChatGPT, it may all be fiction. It may not be real at all, because it's just predicting the next word. So when an inventor comes to you with a claim and you start to wonder, does this person really have the credentials to be an inventor for this subject matter? That's what Sean is talking about. Is it may raise some questions as to whether or not you want to challenge him a little bit. Because you do have to name a human inventor. And someone saying, I identified this as a great problem, that needs to be solved, and AI gave me the answer. That first part is not invention. Sorry. Go on, Sean.
No, no problem. Yeah, and we have a question in the chat where it was asking, do we see more offensive litigation type applications or defensive freedom to operate type applications? At this point, I've only personally prosecuted offensive type applications, kind of defending or kind of cover what our clients are actually doing. I've not seen any kind of major defensive type applications. But then again, kind of like blockchain, because these things were kind of developed over such a long period of time, kind of the more core things about artificial intelligence, the types of models themselves, which you would think would be good defensive type applications, they've been in kind of the public realm for so long that there's probably not a single patent that kind of covers, a machine learning algorithm, a basic type thing like that that is being asserted. But me not being a litigator, I can't say that there's any particular defensive patents I can think of that have been used in litigation. There hasn't been, to my knowledge, too much litigation about AI patents beyond 101, and we only have really one decision on 101 that we'll talk about later. So, Chad, I don't know if you know of anything different.
Oh, I think we're going to see decisions really based on the 101 abstract idea. So Trish, thank you for that. That was a great question. Rick Neifeld, I would recommend everyone read his comment. It is perfectly on point and something that I only regret that I didn't say before. The counter argument, the duty of it to inquire about inventorship, saying it was on AI is a reasonable inquiry, but what he's saying here is legally the inventor is the first to conceive, recognize the conception, recognizing his conception, the AI output and understanding it are qualifiers as conception. Oh, qualifies as conception. Those are all true. Again, AI is helping you. It's not coming up with a conception. And it's also, to a degree, you get fuzzy on the reduction to practice part of that because, what is reduction to practice if not doing research to figure out how to do something to get it to resolution? But the counterbalance, the yin on that yang, is that it can't just be informing someone of the state of the art. And so when those two have to always be considered together. And that's where I have trouble right now. I don't know where the balance is. That's why we have to inquire about what they did and how they did it to get an informed decision. And the last thing about recording it all, how do you even record it all? But the only thing I could think of that if I ever do ask an inventor to record it all, it would be, a lot of these AI services will allow you to retain all your prompts. So you'll have the entire string and maybe you could keep a copy of that. But man, talk about, a document that you may not want to see, may not want the world to see. At the same time, you don't want to hide anything. You have a duty of disclosure. It's a balancing. So to get the practical aspect of it, and Rick, if you care to comment further on this thought, is I would say that if you are in that troubled zone where you're concerned that it may be material to the patentability, then I would say ask them for them to download and save you a copy of their prompts and the responses, the whole dialogue.
Yeah, and that kind of goes. We just also got another comment about interacting with the LLM, kind of how if you consistently interact with an LLM, ask it questions, ask it to refine, and selecting the best responses to move forward with, is that not a form of reduction to practice? Again, it's going to be a balancing factor. What are the questions it's asking? Can you see that the inventor has the basic knowledge of what's going on? And also, so everything, unfortunately, all of these, it's just a balancing act. But kind of on a more philosophical, large level, if you just say, oh, this inventor interacted so significantly with this LLM, look, he asked it 900 questions in a row, and because he was prompting it for something, that doesn't necessarily show that he has conception of the invention. It could just mean that he doesn't know what it's saying to him. But on the other side, it could be him having a very deep understanding of the technology and wanting to find out more and more specifically. So again, it's going to be a balancing factor on what is going on. But necessarily long prompt interaction history with an AI model is not necessarily indicative of introduction to practice. So it's again, it's going to be a balancing act, and right now it's going to be a personal call on all of our parts.
We're going to end up running out of time, but I do have to throw out this because we have an
Mhm.
interactive audience, and thank you for that. Here's my question. Two inventors come into you, two human inventors come into you, and they say they're co-inventors. I don't really question that unless there's a reason to, and sometimes there is. One of the inventors now is AI. So the predicate is AI did contribute to the conception of the reduction to practice. Do you have to have the first claim include the human contribution? The broadest claim, if you look at it and you see that long string of stuff and you realize it all came from AI, does that mean that you're not naming the proper inventor? Because the broadest invention you're claiming is not human. And I think I have my own answer. I would love to hear uh, from everyone else.
Yeah. I know we keep getting questions on this topic because I know it is a kind of open abyss at this point, but in the interest of time, we'll move on and we'll answer questions personally in emails if we can at the end of this, if we don't get the time to come back. Um, but also in the interest of time, the next kind of couple of slides deal with subject matter eligibility of artificial intelligence applications. And so because we're again short on time, I'm not going to run through the Alice Mayo step analysis that goes into 101. I'm going to assume most people here probably are familiar with it. But essentially it's asking, is the claim directed to a judicial exception, is kind of the overarching aspect of what the two-step process is. And the USPTO has given us several examples recently about showing how to apply that to artificial intelligence claims. We have examples 47 through 49. Here, 47, we had three claims. Claim one was directed to a specific hardware element that was executing and was associated with the technical improvement in the artificial intelligence realm. And so because there was specific hardware, there was no real question as to whether or not it involved patent eligible subject matter. It was found eligible. Claim two, on the other hand, if you look at it, was simply a method of using an artificial neural network that included steps like discretizing data, detecting anomalies, and analyzing them that a human could do on pen and paper, and was found to be a mental process. And so the claim two was found to be patent ineligible. Um, and claim three is kind of the winner, that we probably the type of claim that we're all trying to right now, because it's not a specific hardware item, because there's not too many applications that I've seen come across my desk that have a specific developed hardware item that's going to be. It's mostly going to be a software application, and this claim is kind of a good example of how you should craft software type artificial intelligence claims.
So I'm going to interrupt just because we are going to run out of time.
Mhm.
There is a slide deck available on the PTO that trains the examiners. There's also these examples are in the materials. I think we have a link somewhere in these slides to them, but
Yep.
in any event, you can go through those. The materials are actually pretty
Yeah.
good. Um, so let's skip this because it's available
Uh-huh.
elsewhere. I'm sorry to do that to you.
That also reminded me, I meant to make an administrative note up top as well. Because we are patent attorneys, we worked on this presentation up until the last minute. So there's an updated slide deck that we will send all of you after this finishes. So there might be some slides in here where you're going, what is that? So we apologize in advance, but you will get a copy of the updated slide deck. So I'm going to skip through in the interest of time, kind of the example 848, and just kind of go to the summary. It was an anomaly detection. It was a speech separation, genetic separation, ineligible. Improved separation and transcription, eligible. So technical performance matters. It was the takeaway from example 48. But again, you can go into the detailed analysis using the subject matter eligibility examples from the PTO website. And then finally, on the matter of subject matter, on the topic of subject matter eligibility, the one kind of court case we have here is recentive. And the major takeaway was iterative training and dynamic adjustments of machine learning models does not represent technological improvement. So that kind of goes against kind of what we were earlier thinking about in this process. And when I say earlier, I mean a couple of years ago, where we thought training was going to be enough. If you developed and trained your own model, maybe that was the threshold that we needed to cross. Now it's a little bit more advanced, as I'm sure it will advance further even after this. But as of right now, iterative training and dynamic adjustments is not by itself enough to push you over the threshold into patent eligibility. That's that the recentive analysis.
Okay. We're going to step back. Rick, make comments on the comments. Rick, appreciate your comments there. I'm glad you joined. You're a valued contributor here. Ramon, I have no idea how to respond to that. I've struggled with it. So that idea about downloading the actual transcript or whatever you call it of the prompts with AI may be a way to get it into an IDS. So that was about the only way I could think to comply. I think it's enough to, you make a determination that it wasn't material to the examination and that AI is not a co-inventor. You might want to put a memo in your file to that effect, and therefore you're not obligated because it's not material to the patentability. That's one way of approaching it. That's obviously not the only one you can. I mean, it can't be the only avenue because you're going to have situations where it's a lot vaguer, a lot more vague, and you want to always side on the air of caution and over disclose if you need to.
Yeah, that's true.
And for Paul Rosenich, you're absolutely right, and that's the reason that inventors may not know they're using AI because it's in the background, but that is actually the point of a lot of people's concern is, does it really matter, where if it's AI or not? Why are we separating AI out from just internet search? And that, I think, is a great point of debate. I wish I could tell you. All right.
Yeah, and all this kind of goes back, like the whole kind of basic point is it goes to this next slide of enablement. What we're really asking all these questions of the inventor, the reason we're doing that is because we need to be able to describe the type of AI models they're using to enable the claims and the invention itself. So we want to know, when we're asking off the shelf or did you create your own, we want to know the type of architecture they're using. We want to describe the training data or the type of data that they've trained the model on, or the type of data that they've used in a RAG type prompt, the data that they have uploaded with their prompt, et cetera. We want to explain how the AI that they're using in this instance operates at a functional level, because that's going to provide us with sufficient disclosure to enable our invention. That's true in the United States, but that is especially true in foreign jurisdictions, especially in Europe. Well, I don't know if we'll have time to get to those slides, but Europe wants a little bit more explanation and detail, especially in this area of what is the AI model, what's the architecture, and what is the data. So that's kind of a brief overview of kind of the AI and enablement part. We just want to make sure that we understand what artificial intelligence is being used and how it's being used. And kind of the same directions go towards the claim drafting. You don't want a black box AI model where you say, I input data into a model outputs this, and that's my claim. That is not going to be enough. And then the AI model analyzes this in view of, like, that is just you inputting data and something happening. The black box means you don't know how it's operating. You put something in, something comes out, you have no idea what happened in the middle. We need to kind of understand that middle part, at least on some foundational level. So claim-specific applications and technical improvements. This, again, what we like to do, especially in our applications for artificial intelligence, is right up at the top, kind of with the summary of the invention, where most of us kind of just put our independent claims into prose. I like to put a paragraph even just before that in that same section that outlines the technical improvements that this application, these claims, are actually realizing. So we have a full paragraph that I can point to if I come to a 101 rejection later on and say, no, this is what the problem was, and this is specifically how these claims below are solving this problem. So that is one key element that I put into pretty much every application, and I probably put that paragraph in parts of it throughout as well. International considerations. I'm going to kind of skip through this. Oh, sorry, go ahead.
Yeah, before we go international, just one point about that. is you really have to be explicit when we talk about improved efficiency, speed, accuracy.
Yeah.
It's hard to claim those things. I mean, you obviously can't claim relative terms, but it's hard to claim the result. So it really I would suggest that you put a paragraph in saying this combination of features results in greater speed as compared to the prior art, accuracy, efficiency, whatever. Without that statement, we've run into problems in the past where it wasn't sufficiently tied to the invention. And, or we didn't say it and we're like, but obviously it just said that we cut out 8 communications and blah, blah, blah. And all those are chances of error and therefore it's faster. It falls on deaf ears, which is I'm bringing up because the next one is European Patent Office. That's where the trouble comes from. One thing is Brian Lynch very kindly threw in this idea about the third-party disclosures. We're going to have a slide on that if we can get to it. But yes, we have to talk
Yeah.
about the confidentiality of these inquiries.
Yeah, we'll skip through to kind of the summary of the international considerations, and you also have everyone on your screen the second poll for CLE credit. So please go ahead and answer that if you want CLE credit. There's a slide in here that kind of gives a kind of a brief chart overview of kind of all those international applications. Essentially, the big takeaway is technical problem, technical means, technical solution. The word technical pops up in pretty much everywhere. So those paragraphs that we were just talking about in our claim drafting and what we like to put into our applications, those also would help you in all these other foreign jurisdictions as well. You want to outline the improvement explicitly.
Just some high-level stuff. Japan's very generous with AI. South Korea does a really good job. China too, but I'm not sure the examination's good, but they grant them quickly.
Mhm.
Israel, sometimes they just follow along with other people because the prosecution is fairly delayed. EPO is the number one. So it's US and EPO are the two places where you really have to be on your
Mhm.
toes. And if you're only able to think about complying with the two of them, just remember the EPO has a different way of handling abstract thought. They basically strike through most of the claim where anything that they identify as abstract thought.
Mhm.
And then say, "Oh, all you have is a computer processor and a memory." And
Yeah.
yeah, that is very difficult to deal with, particularly since their strike throughs are our technical character. But that's where you really need to be much more explicit in Europe.
Yeah.
They're
Yeah.
the European examiners are exceptional people, but sometimes they are exceptionally stubborn in their position. So
Yeah. Yeah. And one of the kind of key changes that happened in Europe recently that I was very happy to see is kind of in the beginning. I think back in 2020, there was a European patent court decision where it was, no, we need to know specifics about the training data. So they wanted the training data, which for a lot of inventors and a lot of enterprise is proprietary information. They don't want that information put into an application and that's going to be published and made public. So, but now more recent guidance from the EPO and in the actual patent code, the European Patent Code, and the examining guidelines, they've kind of outlined a more general theory behind that now is you don't need to disclose all of the input data or the training data, but if that is the important part or a very important part of the invention itself, you at least need to disclose the data features or data categories. So you kind of need to generally just disclose what the data actually is, but you don't actually need to provide all of the data like you kind of thought you needed to for the last couple of years, which was very nerve-wracking for a lot of people.
yeah,
And so that's just, and then kind of this goes into kind of the question that we were starting to answer before, the AI and the patent practitioner. How are we as patent practitioners utilizing AI, and what should we be cautious of in our use of AI? So these are all the kind of the common uses of AI that are out there now. We can use it for invention disclosure. There are there are, even within Teams, I've seen people when they join a web conference, you'll see that their AI bot has also joined the call and it's recording and will provide a summary at the end. So the practitioners are using that in invention disclosure calls to record so that they can have a transcript of what the disclosure was. AI is being used to expand on disclosures that are being given to you. That kind of hits on another question before, like, do we need to disclose that in an idea? So it all kind of ties back. Um, Chad, I think you say something.
Well, no, I just could go ahead with this, but I do want to have comments at
Yeah.
the end.
So, and then we're also, there's plenty of, Chad and I were just at the IPO annual conference. I cannot tell you how many AI vendors were there trying to hawk their wares about their software being able to help us draft an entire patent application in minutes. That's not really true. But essentially, you can use these to ingest the disclosure and get claims written for you and written description drafting, et cetera. But there are best practices in this that are on the next slide that I'll get into. But you can also use AI for office action analysis to get, you can ask it to provide you with a summary of the rejections, a summary of the cited art, draft arguments. If you're a litigator, what some of our litigators have found very useful is if you are going through uh, transcripts of depositions. It is very good at summarizing transcripts or finding differences between transcripts and things, or testimonies between people. It's also very good at providing summaries of, if you have to go through, hundreds of patent applications. It's very good at providing you a chart and a summary and breaking those up into categories, et cetera. That's another way to use it. You can also use it in your response drafting to an office action. It's very, you can put into, a paid version of ChatGPT, provide me with a proposed argument or claim with amending the claims, or provide me a proposed argument against this rejection without amending the claims. And you can kind of compare and use that as a jumping off point. All of that is kind of more in the nascent stage, and we want to be aware of what it's actually outputting, which we'll get into in the next slide. But so the real good thing that current AI is very good at, which I would wholeheartedly recommend you use it for, is proofreading, proofreading patent applications after you drafted them. It's great at making sure that you consistently use reference characters and all that kind of stuff. So that is another use for for using AI in your everyday practice.
That whole topic about how to use these tools is probably another great Panitch
Yeah.
Training Academy. Let's before we go too far, because we are down to 4 minutes. Ramon, so you're right. Uploading anything into ChatGPT will train ChatGPT unless you're on a pay site. You do, as a patent attorney, have to be aware of what it is that you're sending it to and how it's used. All the vendors at that IPO and just generally have very detailed privacy statements about how the information is being used, how it's not being used for training, how it's not a public publication. And I don't think there's much question you can pay for that level of security so you're not breaching confidentiality of your client and not blowing your rights because you published your invention too early. But you have to read the contracts, and there's one that was literally a packet of probably 100 pages. But it was great because you could send it on to your client and really calm them down about that particular issue. The other question is enablement. Yes, thank you, Paul. That is an excellent point. We do, you can't get enough tie between the claims and technology at the EPO. And when I say something about the examiner somewhat anchoring in the reasoning, they're very smart people, very educated, and they don't have the time pressures that we have in the US. But that often means that they'll form an opinion and it's unshakable. So you don't want them to form an opinion that you didn't disclose enough. I have not seen AI patent portfolio valuation, but that has to be one of the better areas for this, because you think about patent portfolio valuation, it is bringing in a myriad of factors that are far beyond one person's comprehension. Again, I think we should have another thing just on how to prompt for patent practice, prompt AI for patent practice.
Yeah, most likely that would be a good one. And then kind of just as a closer here, the just kind of over your best practices that you want to keep in mind when you're using AI as a patent practitioner. The number one thing is, remember, models are only as good as the data they are trained on. So you have to be aware of hallucinations. ChatGPT will give you wrong answers. So you just have to be aware of that. Also, Chad kind of touched on this, privacy concerns. If you're using, say, the public version of ChatGPT, it is using everything you put into that to train its models. So is that public disclosure? Most likely. Can you actually access that public disclosure? That's probably a whole nother topic as well that we could spend another 15 minutes, 20 minutes debating. But just keep in mind that you want to avoid entering confidential data and documents into, at the very least, into public publicly free versions of any of AI models. And then, like Chad was saying, we could also probably spend an entire hour on the next point. But when you're using AI in your practice, you want to utilize specific and detailed prompts. We found in our own practice that it's best to go step by step in certain things. So if you're, say, doing an office action response and you're using AI to kind of help you out, it's best to have it ingest the office action itself, summarize the office action, learn the examiner's rejections and all that point, then ask it, how does this apply to the claims? Then ask it to summarize, how they utilize, how the claims compare to the cited references, et cetera. Walk it through how you go through your office action responses step by step. Don't ask it to just say, here's all the documents, generate a response to this office action for me. That's going to get you a subpar output versus going step by step. And Chad, I'll let you, this last one is, I know you constantly tell me about these 5 things, so I'll let you cover that in the last minute.
Constantly. Yeah. We're out of time, but I will say when you're prompting, say, I am a patent attorney who are working on an office response to an office action, and I would like, you describe it as you would describe it to a first-year associate, and all that context really does help. Knowing your role, knowing what the task is, knowing the context, as a response, knowing the audience, the examiner. One of the coolest things was sending a response or an argument through, I'm sorry, a European draft application through AI, and it came back with an office action from a hypothetical examiner that was spot on. That was pretty cool. We're out of time. Remember the survey and look for the next seminar, because I think we just talked ourselves into one on just how to use these tools. All
Yeah,
right.
actually. Thank you,
Thank you all.
everybody.